Hey guys, so this one is another video session I promise you to explain the examples that we showed in class already. So I know like this one, I think most of you already know how to do this, but I think I confused you a little bit, like most of you confused a little bit by the very end why we have like two different values and when we're talking about there's only one point of intersection or two points of intersections. So I'm going to explain this one again. So hopefully this time they're going to solve most of the confusions. So like we said before, when we have a linear function, so which this is my linear, and this one is my quadratic. So when we have like the linear and quadratic are intersecting with each other, that basically means we're using exactly the same way as we're looking for the roots. So if we're going to find the roots, there is one very important term that we involved, which is called discriminant. So we have d. So d equals to what? B squared minus 4ac. This one's very important. We need to remember it because you're going to use this one a lot in the quadratics. So how we actually determine whether we have non-intersection, y-intersection, or 2 points of intersection is basically like if d is smaller than 0, then we have none. D equals to 0, we have 1. D is greater than 0, we have 2. So that basically you can see from this one, part B, if I can find the intersection where the values of k over here. So if I find the values of k, if I can make d equals to 0, find the values of k, and then from that solutions, we can determine when d is smaller than 0 or d is larger than 0. So then we can do that. Before we're doing anything, we actually would need to link my linear and quadratics together. And how can we do that? Because you can see start with y, and we are trying to find intersections. What does it mean, intersections? It basically means when these two graphs are cross each other, at which point. So they're going to cross at the same points. Then we can say like at that point they intersect with each other. So that is why in that case the value of y, the value of y are the same. The value of x and value of x are the same. But then let's go back a little bit backwards to inside the question. We don't really care about what is my value of x and my value of y, because the question is asking us to find the value of k or values of k. So it could be like more than one value. So you can see here is more than one. Otherwise it would just say value instead of values. So if that's the case, if you're looking for the value of k, if we don't really need to worry about x and y, so then the first step is for us to link these two together by using y equals to y. And we know that the equations, like the functions are here, y equals to something, y equals to something. And because we know y are the same terms, so that means we can equal the other parts together. So then we start with k minus 2 times x plus k equals to x squared minus 5x. And then I'm going to do the expanding very quickly because it shouldn't really be a problem. We have x outside, so expanding the term. Then we have kx minus 2x plus k. And then we can do the transfer directly. We can directly do the backtracking by this one. So we have a positive x squared, and from right side move it to left side, we can directly take away x squared. And similarly the other one, we have negative 5x, and then transfer it to the left side, we directly make it to the opposite operation, which is plus, and eventually the whole thing equals to 0. And then we can start with some collecting like terms. So we can see, and firstly collecting like terms, secondly write the quadratics back into the way we're familiar with. So then you can see if we have negative x squared. So then usually we put the x squared in front. So then we have negative x squared. And then negative 2x and 5x, we can definitely collecting them. So we have plus 3x. And then kx and k, we couldn't really simplifying it this one at the moment. So we're just adding them up. So just adding them at the back. Add kx, add k equals to 0. And then can we continue with can I continue using my determinant, or can I continue with my quadratic formula? At the moment, not really, because you know the general form or the standard form of a quadratic, it is ax squared plus bx plus c. So that means we only have 3 parts inside this quadratic function. But here we have 4, so that means we would definitely need to continue a little bit simplifying to make everything back into 3 parts. And which part we can continue simplifying? Negative x squared we cannot, because there's nothing can be collected. Plus k, we don't really have to deal with that part because we know k is a value, k is a number, so it doesn't really matter how it's changed. In the end, we're going to have a certain number. The part we need to deal with is the middle part. We will need to get x out and then the other one in the bracket. So we have 3 plus k and then x outside the bracket plus k and then the same way on the front equals to 0. So then here so then you can see here, sorry, I just need to do a little bit more. You already remember the question, so we can start from here. So from here you can see now we have x squared and k. Remember, quadratics, it can involve with x and y. They also can involve with other letters. As long as you have a form which is x squared or something to the power of 2, something continue with something to the power of 1, and then eventually a number. Anything stay in this form, we call it quadratics. So we don't really have to. So x and y is not the compulsory terms in quadratics. The only compulsory thing we need in the quadratic is the power of 2. So as long as we can see a power of 2, we can apply the quadratic formulas, we can apply the discriminant. So in my case, you can see a, b, and c, we still can label them. So a equals to the number, the coefficient in front of my x squared, which I have a negative, so that is negative 1. b is the term that is in front of x, which is 3 plus k. And then in my case, c is the letter k. Why we need to do this is because we are going to apply the discriminant. So then we know d equals to b squared, which is 3 plus k squared minus 4 times negative 1 times k. Alright, so many of you are still a little bit confusing from this one. How can I expand the perfect square directly? So I'm going to show you the way. If you forgot how to expand the perfect square directly, in which way we can do it. So guys, remember the power of 2, it means we are bringing whatever thing we have, the base, like my base can be a number, and in this question we have the bracket. We're actually bring the contents, the content in my base to the power of 2. What does it mean, power of 2? It means, remember, the power is a short way of writing the multiplications. So instead of like multiplying, I keep writing out all the how many times I'm multiplying the same contents. I basically just counting how many times I do the multiplication and then make them into the power. So you can see the power is number 2. That basically means I repeated multiply 3 plus k by 2 times. So that is why we have 3 plus k times 3 plus k. Then here we can directly do the calculation. So negative times together gives me a positive. So negative 4 times negative 1, positive 4 times k is plus 4k. So we can do the simplifying directly. And then d equals 2. So now we can start with, from the first bracket, the term in the first bracket times the term, so the first term in the bracket times the other terms in the other bracket. So that will have 3 times 3, 3 times k. And that's similar like the other one, k, the second term in my first bracket is k. So we can have k times 3, and then k times the second term. So basically the first term times the bracket, second term times the bracket. That is how we expand it. Then we have 9. Sorry guys for the noise in the background. So 9 plus 3k plus 3k plus k squared plus 4k. And then d equals 2. Now we can start collecting all the terms together. So we have 3k, 3k, all the like terms, and 4k. So 3k, 3k, 4k, that's definitely 9k. 10k. So we put 10k in the middle. And because now we start with number 9, ending with k squared, that is not really the way I'm familiar with the quadratics. So that is why we swap the position, make k squared in the front, plus 10k plus 9. Alright, so now we have the discriminant staying this way. So guys, you can see this. Like what I said before, x and y is not the compulsory or the very necessary terms in the quadratic. As long as you have the power of 2, this is a quadratic. So that's why you can see in my discriminant, now I get rid of all the x, get rid of all the y, we only have the term k over here. So in this case, that means it is still a quadratic, it just doesn't really have x and y in it. But can I still use all the method that I can solve quadratics in this one? Of course I can. So that's why, guys, let's go back a little bit. So now we know the discriminant is k squared plus 10k plus 9. There are 2 ways for us to solve it. We need to start solving my questions. Remember we said start from the part B, start from here. We need to make d equals to 0. So that means when d equals to 0, we have k squared plus 10k plus 10k plus 9 equals to 0. How many ways can we solve it? Remember, we are not really... to be really honest, I do... so there are actually 2 ways. I will show you both of the method of how to factorizing this one. You choose which one that is easier for you. So remember, all the quadratics, doesn't matter, I can factorizing it fully, I can do the perfect square, I can do the difference of difference, or the difference of squares, or I can basically cannot really use any of these. I can only apply the quadratic formulas. Quadratic formulas is the basic rule for all the quadratics. So it doesn't really matter. All the other ways is to simplifying your process. But quadratic formula is the solutions that you can always relying on. I know that is a very long formula, but eventually you can solve literally everything by using that if this involves with quadratics. So that is why we're going to start from there. We know the quadratic formula, it means we have, instead of like x, now we have k. So k equals to 2a 2a at the bottom, and then negative b plus or minus in the square root delta. You guys don't really use the term delta. D, the discriminant. So in my case, I still need to determine the discriminant. Don't get confused with why I already had a discriminant over here, already doing my discriminant here. Why I need to do it again? Guys, because we are facing 2 different quadratics. The one you determined before is the quadratics from the question here, which equals these 2, did a lot of simplifying, and remember, eventually you got something like this. So your first quadratic was this one. So then the discriminant you were using is from these quadratics, when we still have x and k both involved. And then when we continue simplifying, continue applying the formula of discriminant, we get to this one. And then you can see the discriminant, according to my previous equations, are also a quadratic equations or quadratic functions. So that means I can apply the exactly same procedure again. So that is why in this case, we are going to determine the discriminant again. So instead of like the first discriminant, we can definitely label as discriminant 1 instead of just discriminant. So then in my case, we can say A equals to the number in front of k squared, which is 1. B is the number in front of k, which is 10. And then C is the number by itself, which is 9. So then it is very easy to determine k, because k either going to be 2 times 1 gives me 2, so 2 times 1. And then negative b will be negative 10 plus or minus the discriminant. So let's very quickly calculate the discriminant time. So d1 equals 2. So 10 squared minus 4 times 1 times 9. So your d1 equals to what? 100 minus, so that is 4 times 1 times 9, that is 36. 36 square root of 36 gives me 6. Oh, sorry, I made a mistake here. That's why I'm saying why it's not really making sense. Sorry, I forgot, sorry guys. Let's forget about this discriminant. We're going to do the discriminant under square root directly. My mistake. Sorry guys, sorry. What I'm doing. Yes. Sorry, I don't really know why I put the square root. So forget that one. Sorry, I made a mistake. So d1 equals to b squared, which is 10 squared. Take away 4 times 1 times 9. We don't have the square root here, my mistake. So that's why d1 equals to 100. And take away 36. And then d1 equals to what? 64. Yep. So then if I know d1 is 64, then that means over here under the square root we have 64. So k equals to what? Negative 10 plus or minus 8 over 2. So that means you have two solutions of your k. So k either equals to negative 10 plus 8 over 2, which gives you negative 1, or k equals to negative 10 minus 8 over 2, which is negative 9. So either way can work. And if I don't really want to use the quadratic formula, so you know, like, firstly, let's need to determine we are actually finished solving with this one. So when k equals to negative 1 or k equals to negative 9, when for both values, that is why you can see here they're asking you to find the values. When k equals to these two values, they have only one point of intersection because d equals to 0 in this case. If I do not really want to use the discriminant or the quadratic formulas, there is another way for us to solve or factorizing this. So I'm going to use method 2. So we have k squared plus 10k plus 9 equals to 0. We can factorizing this one easily and then apply the new factor law. So you can see k equals to k times k. 10 times k gives me k squared. And then number 9, because we need to use these two terms to make the middle term, we already have k. So it doesn't really matter which way k already here. K will be already existed here. We need to make the number in the middle. So from a number 9, I need to find the product of this number. Product means a number times another number gives me number 9. So how many ways can I make it? I can either have 1 times 9 or 3 times 3. That is the only two ways because I'm only looking for the whole number factor. 3 times 3, like 3 times 3 Obviously, I couldn't really make a number 10 out of 2 of the 3's because 3 plus 3 gives me 6. So the only way I can use is 1 and 9. And also because everything we have here is an addition. So then in that case, I don't need to worry about is negative or positive or how to calculate that. We don't need to worry about it. So everything can stay with positive in this case. Then we know this one I can easily factorizing it into k plus 1 times k plus 9 equals to 0. So then apply the new factor law. It means either k plus 1 equals to 0 or k plus 9 equals to 0. As long as I have one of the bracket is 0, the whole result will give me the result as 0. So that's why k equals to -1 or k equals to -9. So if you want to use this way to do your calculations, then you can see we have exactly the same answer. And how we're answering it, basically the same way. So when k equals to -1 or k equals to -9, we have 1 point of intersection. So that means part B already solved, and part A and part C, how we solve it. It is actually much easier than you think. What I actually did in class is I confused you with the sign diagram, which I'm not really a big fan of the sign diagram, but unfortunately that is actually an easier way. But at the moment, since you are very beginner in the quadratics and still not really very familiar with all this sign, all of this simplifying and factorizing, so the sign diagram sometimes can even confuse you more. So instead of using the sign diagram to show you this one, I'm going to do the quadratic graph with you directly. So now we're going to solve part A and part C. We can do them both at the same time. Why it happens like that? It's because again, guys, remember, you are now dealing with x and y. So some of you having this problem and asking me the questions before, like why we already have k and now we have x and y and everything being mixed together, and I get so confused. Guys, don't get confused. Just focus on what the question asks you to find. They ask you to determine the value of k. So that basically means you're only going to analyze the quadratics that only involves k. All the other ones is for us to get the term k by itself. So you can see here from this one you have x and k. Do I still need to worry about this one? Obviously we don't need, because this one going to tell us eventually what is my x and y value. But in my question I don't need it, so I don't need to worry about that. The only one we need to worry about is the second discriminant we were doing, which is this one. This is the only quadratics that involves only the term k and the numbers. So that is why we are using this one to do my graph. And what the graph will look like for this one. So guys, firstly let's do x-axis. And then we know when k, when we need to do the x-axis, yes. So we know when x equals to -1, or k, so when k equals to -1 or k equals to -9, we have the solutions. So we have actually these two solutions equals to 0. What does it mean equals to 0? That means we are intersecting with the x-axis. So that is why -9 and then -1, that is what I'm looking for. And then have a look at the quadratics we have over here. In front of k, we have nothing over there. So what does it shows me? It doesn't really have a negative sign. It doesn't have a negative number. That basically means I only have a positive number and I only have a positive 1. So in that case, my quadratic graph going to be concave up. So that is the only thing tells me that it's going up instead of going down. So that's why my quadratics, I don't need to worry about the y-intercept, because in this case, I don't even need to analyze that. We just need to do like a very simple quadratic graph like that. And then you can see between -9 and -1, that is my solutions when y equals to 0. And then we have my quadratic like that. So then you know when x equals to 0, sorry, when we want to have d equals to 0, then we have these two solutions. We already determined that. So d equals to 0 shows me the number of intersections, and then that one tells me the value of k. So how many values, so how many k's we get doesn't really involve with how many intersections we will have. So we could have 2 k values. So if the question being changed into other way, we can have 3 or 5 k values. It still tells me as long as I get my k value from d equals to 0, that means my whole question over here, so the main question over here, it gives me, this one only gives me 1 point of intersection between this linear and this quadratic. There's only 1 point. My k value can be so many ways, can have so many multiple k values, but my intersection will remain only 1. Okay. Then the second one we're looking for is, so for part A, because we have non-intersections, so that means d is smaller than 0, not k, d, the capital letter D, the discriminant, is smaller than 0. And in this case, how can I determine which part is smaller than 0? It basically means as long as my range is below the x-axis, which is over here, all the numbers, like any numbers in between here, will give me a d value that is smaller than 0, because you can see the graph is actually below the x-axis, which below y equals to 0 or d equals to 0. So when we have these values, then d is a number that is smaller than 0, it's a negative number. So that's why my k is in between which two values? -y and -9. And we're not including them, because if I include them, I'm going to have d equals to 0. So then we have d is greater than -9 and smaller than -1. And then for part C, we were looking for d is larger than 0. So then very easily, guys, which part of my quadratic graph is larger than 0? When my graph is keep going up. Then how can I determine my k value in this case? So we have k either going to be smaller than -9, again not included because I do not want d equals to 0, or k is larger than -1. So then you already solved all of your questions. So hopefully this one tells you a little bit more about how we determine these questions and why we have so many quadratics, but we're only analyzing this one because that is what the question asked me to do. We are only doing the value of k. Alright, so if you have any more questions, just ask me in class or ask me on Teams. I will try to solve it as much and as soon as possible. Thank you.